structure of the CL program, where we look at the if conditions and stuff like that. And chapter 7 talks about declaring program variables. So it goes into the data types and stuff like that, right? I want to give you guys an activity to work on in a group first. So I'll be putting you in breakout rooms. So there are 2 questions that you will be answering as a review. One question will be from chapter 6, and one question will be from chapter 7. So if you go to the end of chapter 6 in your books, you will find question number 10. Is that page number 90 for you? Or if you're using ebook, it may be a different page number. But go towards the end of chapter 6 under the questions. Question number 10, did everybody find that? Okay. It's about, in figure 6.9, you saw a completed CL program. This program contains several CL commands. Find and research these commands. List the commands and the functions that each provides that question. Okay. Then go to chapter 7. It's page 106 in the book, in the physical book. And in chapter 7, question number 12, which is about list the values assigned to each variable data type if the variable is not initialized. That one. Okay, so those are the 2 questions from pages 90 and 106, chapter 6 and 7. So what we will do is 20 minutes enough for you guys, or you need more to do these 2 questions? Okay, Dylan has, let's see what happens, right? Okay, so let's put you guys in those rooms and let's get you started. So there are rooms of 4 or 3. Welcome back. As we were in the activity, I know a couple of people join us. So Oliver joined us. I believe Tyler is still not here. So we'll mark Tyler absent. And Josh is here. So mark Josh present, Josh Harden. And Sebastian is also not here. So we'll mark him absent.
There we go.
And Dar is here, so we'll mark him present. So we are missing Omar, Sebastian, and Tyler. Those are the 3 people missing. Everybody else is here.
Yeah, sorry I was late. I got talking with my English professor a bit after class.
That's what I thought, because you have another class that is right before this one. So it's understood that you probably were there or maybe driving back.
Yep. Just a little bit of both.
So, okay. So chapter 6, question number 10. You guys got that one done?
Research, yeah.
Yes, okay. So how many commands?
1, 2. I believe we got 6 here.
Okay, so which ones do you guys have?
We have like DCL for declare. We
Okay.
have declare processing options.
Okay.
Retrieve user profile. Um, Copyright. All
No,
right.
copyright. Okay, okay.
And then monitor message and retrieve user profile.
Okay. Anybody else has anything more from figure
I mean, I'm not for sure, but I'm pretty sure we didn't go over and do.
Yes, we didn't ask. And do is there. Okay, so if and do is there, there must be a beginning of that and do. So what's the beginning
Yeah.
of that and do?
Do while.
Do
Yeah,
while.
do well.
Exactly. Okay. Is there any if condition in that example?
If else.
Yeah, exactly. There is an if there, right? Okay. Do we have any send program message in that example?
Yeah.
Yeah, okay.
I think there's a couple of different ones.
Right. And then you probably may have a command called receive message. Do you have a receive
Yeah.
message? Okay. Okay. So a lot of commands there. So send program message sends a message to a named message queue or to a call message queue. And receive message is used by a program to receive a message previously sent to a message queue. So there are several commands that are being listed in that one program. Now, number 12 in chapter 7, page 106. What do we have there? Where you list the value assigned to each variable data type if the variable is not initialized. So,
Char is blank.
okay.
LGL is 0.
Uh-huh. In quotes, single quotes, right?
And,
Yeah.
Decimal integer and few ints are also zeros.
Yes. So
Okay.
decimal, integer, and unsigned integers are 0, but no quotes.
And then the pointer can't be specified.
And then
Pointer
DEC
is
is 0.
yeah. And DC 0, yeah. So that DC int, uint, they're all zeros. And pointer is no default. An address needs to be specified. So that takes care of that. Awesome. Good job. Good job. So next, I have another item for you guys to look at. Okay. Go to chapter number 7, exercises. Which is right after the questions, review questions, exercises. Okay. Now let's do this one together. So if you're looking at in exercises, question number 1, determine which of the following variable names are valid and which are invalid. Is everybody there?
No.
Yeah, okay. So let's start. A, valid or invalid?
valid.
Valid. B,
Valid.
B
No.
is invalid because
Yeah.
it must start with letters, right? And that was
Yeah.
numbers, right? Okay. What about C?
I think we need to start with an ampersand.
Yeah, so
So
it's
it's invalid.
exactly, it's invalid. Okay, number D,
Invalid.
invalid.
Because it doesn't start with a letter.
It doesn't start with a letter. Um, E,
Valid.
valid. F,
Valid. Wait, no.
no.
Is that the 10 numbers?
Yeah, it's too long. It's not valid.
Tricky.
G,
I think that might be valid.
that's valid, right? Yeah. H,
No.
Valid.
no, must start with an ampersand. Exactly. I,
Not valid.
that's valid. Hashtag can be there in the first placeholder. Underscore is not allowed in the first placeholder. Hashtags, @ are allowed. Okay, so I is valid. J,
Valid.
valid. Okay. K,
Valid.
valid. L,
Not valid.
Invalid.
invalid, no spaces. Okay. And M is also valid. $signs are allowed in the first placeholder. Okay. Now let's go to question number 2, where you determine the initial value and length of the variables. So for part A, what is the value in the variable and what's the length?
The variable would be DEC.
No. The question asks you to give the value and the length. Okay.
Oh, the value. 16 is the value.
Uh-huh.
The value is 16.
Right. What's length? What's length? How much length do you need to store 16?
One byte?
How many digits is 16? How many digits is 16?
16.
16 is how many digits? Like, is it 1 digit, 2 digit, 3? How many digits are there in 16?
Oh, 2.
2. Come on, guys. So length is 2. Okay. B. What is the length and what's the value for part B?
The length is 2.
No, the length is not 2 for part B. The length is stated in front of character. The length is 10, right? It says that,
Oh, yeah.
right? Okay, what's the value? Come on, we just did that in question number 1. What is the default value of
Length.
character?
Length.
Yes. This is where you apply the knowledge, right? Okay, C. What's the length of C and what's the value?
The length would be 2.
Right,
And the value
Yeah.
would be 0.
right. Because we just did that in question number 1. Okay, D. The value is pretty understood. It is there, 154.6789. That's the value. What's the length?
7 with 4 decimal places.
Exactly. So it's 7 space 4. That's the length. Okay. E. What's the length and what's the value?
1 and 1.
1 and 1. Okay. Length is 1, value is 1. F.
Memphis. 7.
7. Memphis 7. Very good. G.
Blank. Oh no.
Okay. Blank. What is the length?
Characters.
0.
For a reason, I made you guys do question number 12. Question number 12 of the questions from chapter 7. So character data type, if no length is given, what's the default length?
1.
No.
Default length, 32 bytes.
Yes, exactly. It's 32. 32. So for that one, the length is 32 and the default value is blank. Okay, part H. Length.
8.
Length for
Oh,
part
15.
H.
Length is 15.
15 and the value is
555.
555
hyphen 1212. Okay, awesome. I, what's the length?
4-3.
4.3 and the value is 3.625. Okay. Now let's look at question number 3. Consider the following variable declarations which are valid and which are invalid. For those that are invalid, explain why. Part A, is it valid or invalid?
Invalid.
Invalid. Why?
Okay, data type.
Exactly. It's missing the type. Remember, we're not just looking at variable names. We are looking at to see if that is a complete declaration. Okay. So every declaration of the variable must have a data type. Part B.
Um, I want to say
Valid.
valid.
That is not valid because notice we are using positional notations. In positional notations, length cannot come before the data type.
Yeah.
Okay, so 3 should be after character, not before. Okay, so we got to change the sequence. Okay, now look at part C. Valid or invalid?
Valid.
Valid. Okay, that's
Using
valid.
keyword.
So we are using keyword notations. It doesn't matter. The sequence doesn't matter anymore. Okay, now part D.
Valid.
No,
No.
part D is not valid.
Right, the 10-0 is like for decimals.
Exactly. So
And
there
that's
should not be any
Oh.
0 in the length. It's a character data type. It should be just 10. Okay, E, valid or invalid?
That one's valid.
That's valid. F,
Valid.
no,
Yeah.
no. F is not valid.
No length.
The length of the variable is more than 10 characters. The word country name is 11 letters,
Yeah.
right? Okay, G,
It doesn't have the length in it.
that's okay.
It's valid.
It's valid. And H, see, when you do not put the length for decimal, it defaults to 15 digits, which allows for 5 decimal places. Okay, so that just to answer the previous question. Okay, okay. So what is the next one? H, is that valid or invalid?
Invalid.
Valid or invalid?
Invalid.
Invalid. Why?
The value's too long.
The decimal places cannot exceed 9. Right? There are way too many decimal places here. So according to this data type, decimal places can be maximum 9. Okay, I, invalid or valid?
Invalid.
Invalid. Why?
Because the value's not a character. No
Right.
quotes.
Right. So the value needs single quotes. J,
Valid.
invalid. Same problem. Single quotes missing. Okay. K,
They're valid.
valid. Yep. L,
I'll say that is valid too.
no. Just look at K. The value of K and the value of L. You see
Oh,
the
no
difference?
quotes.
No quotes. Okay. M,
Invalid.
invalid. Why?
No quotes on the number.
No quotes on the number. And then N. N is in Nancy.
There's no decimal.
It'd be valid.
It'd be a weird
9.
stick code.
17.9. No,
Or-
it's
Yeah,
not
too
valid
long.
because max is 15 digits.
Yeah.
You can't have more than 15 digits. So that's why it's invalid. Okay, now let's look at question number 4. We are only looking at the values to see if values are valid or not. Okay, part A. And remember, these are
Invalid.
all character values, right? Which of the following are invalid character values? So we are assuming all of these are character variable values. So yes, invalid must have quotes for part A. Part B,
Invalid.
invalid,
With
same
quotes.
reason. Part C,
Invalid.
no, it's valid. It's a hexadecimal value for
Oh.
an X outside of the single quotes. So it's valid. D,
Valid.
valid. E,
Invalid.
invalid. F
Invalid.
and G. Oh, no, F will be valid because character allows you to give a character only value. If the value has all characters, no numbers, and if it is only one word, it is allowed. G,
I think that's invalid, isn't it?
G is valid because the value is in
Oh.
quotes, single quotes, right? So that's
Oh, you
perfectly
can
fine.
do the quotes like that
Yeah.
in between
Say it again?
parentheses. So you can do the single quotes like that in between parentheses.
Yeah, exactly like part D. Look at D. Today's Sunday. That's in single quotes, right? So the same rule
Oh,
applies.
they technically count as the same thing.
Yeah,
Well, not the
because,
same thing, but similar.
yeah, but because it's in single quotes, so you can just put anything in single quotes as long
Mm.
as the data type is character. H,
Valid.
valid. Same rule as F. One word, all letters, single quotes not required. I,
Invalid.
invalid. Okay. The only reason will be valid if it's for system value. Okay, which of the following are invalid decimal type? Question number 5. Part A,
Valid.
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 B,
Invalid.
Invalid.
invalid. C,
Valid.
valid. D,
Valid.
valid. It's all numbers. Okay. E,
Invalid.
invalid. F,
Invalid.
Invalid.
invalid. G,
Valid.
no. You
No.
can't put dollar signs.
Can't
Invalid.
put dollar sign.
It's all decimal. All numbers. The only symbol allowed is period. H,
Invalid.
Invalid.
invalid. The plus sign cannot be towards the end. The sign has to be before the digits start. I,
Invalid.
invalid. Okay. Now look at number 6 for logical data type. A,
Valid.
Invalid.
invalid.
Oh yeah, missing.
Quotes missing. B,
Valid.
valid. C,
Nope.
nope. Only allowed value is 1 in single quotes. D,
Nope.
nope.
No.
Same rule. E,
Nope.
nope. Same rule. F,
Nope.
nope. Same rule. Okay. Now look at number 7, integer data type. Okay. A,
Yeah.
yes. Valid. B,
No.
no. C,
False.
No.
no. Because it's integer. Decimals are not allowed in integer. D,
Yes.
yes. E,
No.
No.
Yeah. No.
No.
No. The
no.
quotes.
Single quotes are not allowed. In E, you have single quotes around -45.
Yeah.
F,
Oh.
no. No hex numbers. Okay, now let's look at question number 8, unsigned integer. Part A. Yeah, part A. Part A for number 8.
I'm gonna go with yeah.
Yes, okay, part B.
No.
No.
No. Part C,
No.
part B,
Decimal.
D,
Yes.
S. Part E,
No.
no. Part F,
Oh.
No.
no. Okay. So that's why I gave you guys that table to fill out for number 12 so that you understand the different values can be assigned to different data types. So that's why we did this exercise together to see, how things will be done in your declaration parts at least. Okay. So having said that, well, now I want you to look at programming assignments. And I will be putting you guys in a group of 2 people. So for you to do question number 1 of chapter 7. So
What
that
page is that on?
yeah, so you will be put in a breakout room of 2 people in that group, and you will be working together to solve that problem. So let me create the breakout rooms, and in the meanwhile, you guys get to that.
Question 1 or exercise 1?
Yeah, exercise number 1. So which is chapter 7, exercise 1. Everybody got that?
You mean programming assignment?
Yes. Under programming exercises, which is after these questions. So you have your exercises that we were working with. Right after that, you have your programming assignments. Did everybody find those?
So in this assignment, you practice declaring variables for use in the CL program, that question? Or
Yes.
add program?
Yes. That one that has
SA 0701 XXX.
exactly that one.
Right?
Okay, hold on a second. Let me move things around here.
So many grays here.
Okay, so there'll be groups of 2. There'll be, in each one of them. Okay, just 1 second and let me organize these, okay? Just give me 1 minute here. Jose, can you answer that question I sent you in the chat?
Oh, yes, that's fine.
Yeah, okay, cool. That's what I thought. So I will give you guys 15 minutes to work on this one. So I'm opening the rooms.
Let's get in here.
Share my screen here. Okay. Everybody see it okay?
Yeah.
Okay. So this was the common section that I was talking about.
Where did it go?
Okay.
Okay. And after that, we have the variables declaration. And after that, we have the variable display information. Now, tax rate being a variable of type decimal requires a conversion. That's why we have used the percentage character as we learned last week, that you have to convert because it doesn't automatically converts. a non-character to a character, even if you're using concatenation. So you have to convert a non-character to a character object, to a character value.
Can you go back to the top for a quick second?
Yeah.
Okay.
That's all.
Now we haven't reviewed these functions yet, right?
We only reviewed one of them, which was character.
But is it in? It's not in before chapter 7,
No,
right?
no, no,
Okay.
no. That's why I only included one of them so that we can complete our last week's work. But
Okay.
I know the book is not the best, the way it's written. And
Oh,
I don't know why it was written that way. I have no idea. I'm not the author. I had no say in it. I would have written this book very differently if I were to write this book. As you guys started looking at the code from chapter 6, you guys would have seen a lot of stuff in that example, 6.9, that has not even been talked about in the book yet. So, like receive message, for example. So there are a lot of that thing, you know. So this will let you see the whole code. I just deleted one extra blank line I had. So this is basically the gist of the program.
now, can you run this program from RDI and see the messages?
Yes, I have not taught you guys that yet. I will
But
be
yeah.
in the coming
Okay.
classes.
Oh,
That
okay.
Yeah,
Now,
how to set up RDI to run.
can you run this one for the fun of it?
Yeah, I'm just waiting for people to catch up with the code that
Okay.
they're copying. And yes, I will run it
Okay.
after that. Yes.
Okay.
So when you compile it, so just running the compile here, and it just is a warning that I have a variable that I did not use. That's about it.
Mr. Yusuf, couldn't you grab a system profile and then put it to the value of the user variable? Or no?
What do you mean?
It
Oh.
said on
You can read the user profile through a command, yes, but you didn't have to do that here.
All right. I just got confused because it said with an initial value of your system profile. So I was confused if you had to grab the actual.
Yeah, whatever it is your user profile, you could have hard coded that.
All right, thanks.
So for those of you who are running this program, as I ran my program here, notice you will see no output in the line below. The reason you will not see any output because my first send program message is displaying time and time is empty. I did not give any value to time. So, but you see a little plus sign at the end of the line. So what you got to do is you got to page down. Since I'm a Mac user, I'm just paging down by using function and down arrow key. So now I start seeing values, value, right? So that's what it is. That's why you basically saw that, it was not displaying any output, but that wasn't the case.
I have a question. If maybe you can explain this to me.
Okay.
From other editors, like if you're using C#, you write your program, save it, compile it, and then you run it.
Mm-hmm.
And you see your stuff on the screen.
Mm-hmm.
We cannot do that in RDI.
This is
You
a
have to
low-level language because it's a low-level language. It's not a high-level language.
Oh, but okay.
Okay, it's a low-level language. That's why it doesn't has the interfacing outside of the operating system.
Okay, but even if it was an RPG program, the same thing.
RPG, exactly, because RPG has a different role. RPG is a report program generator. So RPG has no input-output instructions.
Okay.
So that's why for input and output, you have to go outside of RPG. So RPG is just a middleman, which can grab the data, bring it in, or take the data from a form and hold it. So RPG is not like C# or Java.
Okay.
That's
so
why, yeah. That's why
okay,
you
so
need the display files or print files
right.
to work with RPG.
And you always have to go to the green screen to run your programs in this case?
In this case, you can run it from within RDI, as I told you. Then you have to go to the work spool file area within RDI, and that's where you can see the output.
I see, but you cannot run an interactive
No,
program.
no. Again,
Okay.
because it's a low-level language, needs to run and an out. Yeah, it's not one of those other languages that you guys are familiar with. Yeah, exactly. Yeah, it's a different beast. Did everybody get this working? Isaac?
I think I had some syntax errors.
Oh, okay. Okay. How about the rest of you? Okay. So you guys were right on the right track. It's just like you needed a little bit of time to put it all together.
Pretty much.
I got it.
Okay,
running.
awesome. Awesome. So in this program, if you were to sum it all up, What are some of the things that you learn about in this program?
Then messages, yeah.
Let's start from the beginning. What are some of the things that we accomplished in this program?
To send a message and read said message.
I said start from the beginning of
Oh.
the program. What is the first thing in the program?
Declarations.
Declarations, right? So in this program, we learn to declare variables with different data types. We learn to declare a variable and not initialize it with a value. We learn to declare variables and initialize them with values, right? We learn to declare variables in positional notation, and we also learn to declare variables in keyword notation. Does everybody sees all of these things in the declaration? Okay, then comes the program execution section where we issued multiple send program message instructions to display different variables. And then after that, when we compiled and ran the program, we have to page down in our output to see these instructions one at a time. Everybody got that piece? Okay. Now let me make one slight change in this. Let's go back to our program, and instead of time, I want to declare a variable and call it type. The name of the variable will be date. And of course, in the send program message, I will be displaying date. However, over here, I want you to write an instruction or command rather to transfer system date in the variable date and then display it. Let's see if you guys can write that instruction for me. I want to grab the system date and I want to put it in the variable date and then display it. So the rest of the code is there. I just want this piece of information to be coded by you. Write a command to transfer system date in the variable date. The display part is already there. So this is a group activity of all of you together. So if you have any questions you want to put in the chat, go ahead and do that. And let's see if somebody will respond to your questions. So you guys are in it together, all of you. All 17 of you are doing this together. Yeah, I purposely said 17. I'm not included. All the system program message command, everything will be there. Just to answer Dylan's question, you just need to write one instruction above the last send program message, the first send program message command, which will put the system date in the date variable. You will not make any changes to the system, to the send program message commands, other than replacing the time with date. Oh, and Jose, to answer your question, yes, that's what it is.
You couldn't hear me. I meant to send it to the group, not to you.
Oh, well, it only came to me.
Oh, I'm sorry. I don't know what to do here then.
You probably may have to choose everyone instead of me in the chat list.
Okay, let me see.
And then, yeah, and then you can
But
send it.
I don't have an option to choose.
It
It
should,
just has your name, and then next to it, it says, oh, here, yeah, the drop
yes,
down,
yes,
everyone. Oh, I'm
yes.
sorry. Oh, man. We need that, right? To get the date.
Yes, 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 you can share
Okay.
it with the group, absolutely.
Yeah, that's what I meant to do, and it just went to you.
So Jose has the answer for everybody, at least
Yeah.
partial answer. So Jose has shared this answer. That's for the date part. Oh, Dylan, Jose provided extra information that it is the same command that can be used to retrieve date and time. So if you are retrieving date, You will use QDate if you're retrieving time. You will use QTime. You guys are only to retrieve the date, not the time. So he just provided that extra information. So the complete syntax, that's an incomplete syntax. What was given to you is Jose only gave you the command. So the complete syntax would be this. This will be a complete syntax. So retrieve system value. The first parameter is what you are trying to read. And second parameter is where that value is going into. So if I was reading time, it would be something like this. So the first one is reading date. The second one is reading time, but you only had to read date. So the first one will be more than enough for you guys. So something like this. Now, I used keyword notations versus positional. So that's why you see that. I've spelled out the keywords in my solution. So when you compile it and you run it, on the very first line, you will see today's date 02/14/24. And then you can page down, the rest of the values will be exactly the same as before. Okay, everybody got it? Awesome. Okay. How about we take a break over here till 1:35? And then when we come back at 1:35, we'll start looking into chapter number 8. So we'll see you guys at 1:35. Now, let me bring up the presentation, PowerPoint for chapter 8, and then let's start looking at that first. So chapter number 8 is a continuation of the previous chapters that we have already dealt with. Chapter 8 concentrates on manipulating variables with change variable command. So starting out with slide number 2, change variable command changes the value of a variable. Now, in other programming languages, you might have done something like assigning a value to a variable, such as you will say, okay, x is equals to 5. And then later on, you may say x is equals to 9. But you can't do that in CL. In CL, if you want to change a value of a variable, you have to issue a change variable command in a separate line, and that would be the only way that you can change the value of a variable. It is how the assignment works. Assignment statement, character value to a character variable, numeric value to any of these 3 data types, and a logical value to add to the logical variable. In order for you to do the data conversion, you can do numeric value to character, you can do character value to any of the number types, you can do logical to character. All of these conversions are possible. And you already saw one conversion, and that was from a non-character to character by using the character built-in function %char. Now let's look at those two lines at the bottom of this. Now let me push this up and maybe increase the font size, just like that. And as you can see in the very first line, we are using what we call keyword notation. In the second line, we are using positional notation, but doing the same thing. The name of the variable is day of week, and the value that we are assigning to this variable is Thursday. So we're assigning Thursday to day of week in both of these instructions. So if you ever want to change a value for a variable, you will write change variable, variable name, and the value. Okay? If you're not doing it through commands like retrieve system value that we did. Character values can be any combination of characters, usually a quoted string if value includes an apostrophe, code 2 apostrophes. If not quoted string, value is translated to uppercase. Cannot consist solely of numbers, cannot contain a blank, cannot include special characters if you're not putting quotes around. If variable is too short, extra characters are truncated. For example, in this code, the character length is 10, and we have Billy Goat, which fits nicely in 10. But when we change the value of a variable to John Smithson, John Smithson is more than 10 characters long. So what do you think will be the value stored inside name? Yes, guys?
John Smith.
John Smith. Very good. That's it. 4 space and 5 other letters, right? Okay. Value can contain only digits, decimal point, and a leading sign. So sign should be leading, not trailing. Trailing would be an error. UInt, which is unsigned int value, must be a positive value. So if we have two variables, my number decimal and my integer, we can assign a value to my number like this, or like this, or to my int like this, because it's an integer, doesn't take the decimal value. Behind the scene, the decimal representation will be like this because of decimal. Too many integer digits cause runtime error. Extra fractional digits will be dropped from a decimal variable. So there's a bit of a difference between assigning values to integers and assigning values to decimal that don't necessarily fit in the group. Value for a logical variable must be in single quotes. It could be either 1 in single quote or 0 in single quote. If you have declared a variable of type logical and have not given it a value, and you want to give it a value later on, you can do that again with the help of the change variable command. Now comes converting numeric to character variable. If you have a variable of type character declared, let's say of size 11, and you assign this value to the variable, now it will add those leading zeros. So value is right justified and padded to the left with zeros. If numeric value is negative, then it is negative, padded zeros, and then the actual value. So as you can see, all three variations here. Converting character to numeric value. Quoted value must be only numbers, decimal points, and a leading sign. If character value includes a decimal point, the value is aligned with the decimal point of receiver variable. Access character right of decimal points are truncated. So here we have a decimal variable of size 5 with 1 decimal place, and we have another variable of type integer. We are assigning a value to a decimal variable by using a plus 98.6. So what will be actually stored will be just 98.6. Plus is understood. For integer 499.50 will be truncated now. Value parameter may use a variable as an alternative to a literal character or decimal conversion can occur. So variable may be a field in a file. So that's also possible that you've opened a file for reading purpose, and you're grabbing one of the fields from a file that can also be used in place of a value. You can also use arithmetic conversions when you are expressions when you are putting a value in a variable. So if you have a variable count, and if you want to increment the value of count by 1, you can write a statement like this, where the count, it is equivalent to writing count plus plus, or count plus equals to 1. Then comes the 3 different kinds of concatenations available to you for character variable. If you put cat between the character variables, what it does is this. Let's say you're talking about John. John is placed inside a variable B. The total size of variable B is 10 characters. So John is literally followed by 6 spaces. So what this will do is, if you are using cat operation, so let me increase the font size a little bit here. Okay, so if you're using cat operation, so it'll display John, followed by 6 spaces, and will then display I, and will then display D, which is Smith, followed by 5 spaces. So that's how the output will come out. If you're using tcat, which is truncate concatenation, so it will first of all display John. Any of the 6 spaces after John will be dropped, truncated. We'll put I next to John, and then we'll put Smith next to I. So this is basically what the text will look like. Now you'll be wondering, why do I have so many extra spaces after Smith? Because this value is going in A, and A is size 23. So the remaining 13 spaces will be after John I. Smith. For bcat, what bcat does, it automatically inserts a blank when it concatenates. So it will take John, it will truncate all the extra spaces from John, and will add 1 extra space before I. Then we'll add 1 extra space before Smith. So John space I space Smith. That is 12. Sorry, yeah, that is 12. And then the remaining 11 will be spaces because of A being 23. And then the last one concatenates the word dear with a space and a B, and a space and a D. So it is dear space John space Smith, and then the rest is whatever is held inside A. Okay, now comes substring function. What substring function does is substring function allows you to extract portion of a string out. So when you will learn about substring functions in Java and C#, you will see the same thing, that what substring does, it allows you to extract part of the string. So how does it allow you to extract a part of the string? For example, you have today equals to Tuesday, and the day of week, another variable set to 5. So you're saying, I want to change the value of the variable day of week. So I want to substring today, which is Tuesday. I want to, starting from position number 1, I want to grab 3 letters, the first 3 letters. So those first 3 letters are then moved from today into day of week. So the day of the week is now equals to TUE and 2 spaces because the size is 5. Okay. Next comes binary function. The binary function extracts binary numbers from character variables. So binary allows you to work with variable, starting position, and the length. So length must be 2 or 4. Starting position and length can be variables also. So here we have a variable my number and a variable my character and a variable my string. Now we're saying my number, you're converting the my string. You're starting from 1 and the length is 2 bytes. So you're extracting it and converting it from hexadecimal to its equivalent number. Similarly, in the character, you're starting in the my string from position number 3, you're grabbing the next 2 and converting it into characters. This is converting from other data types using substring or binary into equivalent character types. Similarly, you have other built-in functions that can be used along, like substring can also be used instead of as a second parameter in change variable. You can also use it as a first parameter in change variable. In that case, this is how it will behave. If you have a text that holds the value Bob is the boss, and you are like, okay, I want to change the variable of text. I want to change the variable text, but I do not want to change the entire text. I only want to change the word Bob with the word Joe. So you're asking the substring to go to the variable text and replace the first 3 letters, starting from position number 1, with the word Joe. So the resulting output will be Joe is the boss. Then you're saying, okay, I want to replace the first 3 letter with Alfonso. Now, Alfonso is more than 3 characters, so it'll automatically only grab the first 3. So it'll say Alf is the boss. And in the last one, you're saying that, okay, I want to start from position number 8 and start replacing the next 3 letters. So the word the will be replaced with the word not. So it'll say Alf is not boss. And then finally, you are replacing the characters with the numbers. So as a result, you will be converting it into its binary equivalent, 47, into its hexadecimal equivalent of 2F. The address function changes the value of a pointer. So if you want to replace a pointer, which is pointing at one variable, to now start pointing at a different variable, you will use a built-in function address for that purpose. So for example, pointer is pointing at a variable myQuell, and you want the pointer to point at your quell. So you'll say, my pointer, I want you to change your memory address from myQuell to your quell. So since pointer has changed its point of reference from my quell to your quell, so the variable library, which is based on the pointer, will also stop pointing at my quell and will start pointing at your quell. So all the dependent variables will also change their point of reference. An offset function gets or sets your offset portion of a pointer variable. So it allows you to maybe jump whatever number of bytes you want to offset. So it says, I want to offset from the current location of my pointer, I want to jump like 10 bytes. So that's why it affects after the 10 bytes. It just offsets this much portion out. And here, it basically shows you the contents of a CL program inside a spool file, which you guys can go behind the scene if you want to see what is the spool file that was generated for the program. So these are some of the functions that we will now put to practice as we start writing code in the CL. So let me switch over to Okay. Okay. Everybody can see my screen. Okay, I am creating a new member. So can you guys see my dialog box that's showing up, or you can't?
We can see it.
And
You can see it? Okay. So the name of the code, it will be chapter 8, CH8, example 1, CLLE, and finish. Practicing change variable command. So creating the basic program structure, now let's start declaring the variables that I want to use in this example. So let me declare a variable called character 10, type character, size 10. And declare another variable, character 24 of type character size. Oops, character size 24. My bad, should be 10%. And let's declare a decimal If I want to assign a value to my variable or my variables, which command will I use for all assignments? Which command do we use for changing the variable's value? It's right there in front of you. What
It's CHGVAR.
exactly? That's what I wrote in line number 6 in the comments, right?
Yeah.
Practicing change variable command. And that's what we looked at in chapter number 8. So it's the change variable command. So we will be using the change variable command over and over again in this example for each of the variables. So change variable. I want to change the variable, the very first one's value. So I will use let's say, okay, this is my library. Is that more than 10 characters?
Do the spaces count as characters?
Yeah,
They do,
yeah.
right?
Yeah.
Then yeah, it is.
Yeah, everything in the single quotes counts. Okay, cool. I purposely did that. Okay, change variable, character 24, value. Is the second one within 24?
Yeah.
Okay, so I created one variable with a value longer than what it can hold. I created another variable with a value that it can hold without a problem. Okay. Change variable. We have decimal 50, size 5, right? So we're going to give it a value that it can hold without a problem. And we will give it a value that it can hold without a problem. And then finally, changing the variable of the value of my logical variable. And let's give it a value of true. Okay. So far, we have learned that if I want to see the values of my variables, what do I need to do? I need to write send program message instructions. But if I don't want to do it and I still want to see what their values are behind the scene, I can use dump CL program. So I want to see the memory dump. Okay, what happened here?
I wasn't able to create a new source member, so I'm like way behind.
You are not able to create a source member?
Well, it says source physical file when I right click on the ITPA 640. I click there's a source physical file, but there's no source member to pick from.
Okay, just 1 minute. Let me look at this problem first. Not declared. LGL1 is right there. Why is it not recognizing it? Oh, length. Should matter. Length shouldn't matter. Okay, let me try this. Oh, okay, I only put 0 there because I did not use keyword notation. That's why. Okay. Can you share your screen? Let's see what's going on. Okay, so if you right click and go to expand to, choose expand to from the drop down and choose source files. Okay. Now, okay, the last one is your source file, SP24. You right click on it, new member. Okay. So the member is CH08EX1. Okay, choose CLLE and finish. Okay, so it was not doing this for you, or it just
Oh, I just didn't
going
know where
in?
that was.
Say it again?
I didn't know you could expand to, or I couldn't find that.
Oh, okay, cool. No problem. So let me share my screen again. Okay, Dylan, no problem. Check back later on for the recording.
I got you. And then if anything, I'll just ask you tomorrow.
Okay, cool. Okay, so let's have a look at this code again. So that's the complete program. From line 8 through 23. So lines 8 through 23, that's the complete code. Once you've written that, you compile it, and then you run it. I am holding on the screen for anybody who's behind so that they can complete writing the code. You will not see any output because we don't have any send program message. I will show you where to go for your output, but I'll just wait for everybody to be done with this code and is done compiling, and then I will walk you through the process. Okay, so anybody still coding or is everybody done? Anybody still coding?
I got like a couple more lines left. I could catch up though.
Yeah,
I
go
got,
ahead. Complete those couple of lines. So in this program, how many commands are there in the start section? How many unique commands are there in the start section? 2. One is change variable and the other one is dump CL program, right? Change variable allows you to change the value of the variable, and dump CL program takes all these variables and put it into a memory dump so that you can see what is the value of each variable, and it puts that memory dump in your spool files. And that's what we will go and see after we call the program to see how the memory dump looks like. Okay? Oh, second. Isaac, are you caught up now?
yeah, it looks like I have some syntax errors. Or
Oh, you have
wait,
syntax
variable-
errors. Okay.
I got a variable dex72 is referred but not declared.
Which one?
Character.
Which variable it's complaining?
Dex yeah, decimal 72.
Okay, so check your line number 12 to make sure that it matches with line number 18. Because it is basically saying 72 doesn't exist. So if line 12 is not done correctly, line 18 will complain.
You know, I just might rewatch this video and then just try to follow along as I can.
I mean, you're so close. I would let you share your screen. I mean, like for one error, I wouldn't want you to miss out on everything. Share your screen. Let's have a look at it. Okay. So can you double click on your second line? Second line. Second line. Okay. So it is complaining that character not valid following the string decimal, right?
No space.
There should be a space. Exactly. That was the problem. That's about it. So always try bottom up because the last one is actually the first one it incurred. So save the changes and compile it. Okay, awesome. Okay, so what we will do here is, first of all, we will be switching over to the green screen and we'll be making a call. So call chapter 8, example 1, whatever it is called on your end, you use the same combination. So if you call CH08 EX01, then you use that name. Whatever is the name on your end is the name that you use. Hit enter and it will call it. No output will be generated because we do not have any send program message instruction. Now type work spool file. WRKSPLF and hit enter. Work spool file and hit enter. Now press and hold Shift F6. Shift F6, that'll take you to the bottom of your spool file. On the very last line, you will see a QP program dump. QP program dump. That's your memory dump for the program that you just ran. Next to it, choose option 5 and hit enter. And that's where you can see character 10, this is my. Notice the rest is truncated. For number 24, you see this is a long variable followed by spaces for anything remaining. Decimal variables are perfectly fine, and logical variable is a true with 1. So this is how you can actually, when you are coding and you want to see, okay, what is the value in my variable? You can do a quick memory dump, call it, and check the dump to see if your variables have the values that you want the variables to have the values. Because this is how you can look for any logical errors in your variables. Maybe it is not producing a desired output because it doesn't have the value that you want it to have. And so everybody get to see the dump? Okay. Let's F3 out of here. And you know what? Let me delete all of these. It's always a good idea. Delete all your dump. I mean, all your spool file. Okay, my spool file is now empty. Let's go back to chapter 8, example number 1. Now let's save this example as chapter 8, example number 2. And click OK. So we'll have chapter 8. Sorry, it should be CH8EX2. Example number 2. Let me delete from here a few lines. And then actually I want to try. Or rather, let's do this. In this very example, let's assign an initial value. Initial value, John. Initial value, long. Initial value, 6.5. Oh, sorry, 6, not 6.5. And initial value of, okay. So that's all I did. I assigned initial values. Let's compile it. Once it's done compiling, then go to the green screen and call it. Once it's done calling, then check the work spool file and check the memory dump. And you will see that all values are replaced. So it is not John and long, and it's not the values that was initialized with. So we were able to successfully change the values. Okay, now let's do something different here on line number 17. Instead of 1, 2, 4, 5, I want it to be 1, 2, 4, 5 plus 45. So I'm doing a calculation. And this will be times 1.67. So let's save the changes after these two changes. So I'm doing an addition and a multiplication operation with an assignment. And now let's call. And now let's check the spool file. And oops, hold on a second one here. Oh, did I think I compiled it, right? I did compile it. There we go. Okay. So the value is 1290 and the value is 2062.06.
My decimal, the multiplying one didn't work. Give me a second. 1, 2, 3, 4. Oh, that's why. 2, 3, 4. Okay.
Okay. Now let's change this to use the variable from the line above. And that is the one that we will multiply by 1.67. So we are using the value of the variable from the line above in this variable. So using one variable and another variable's value. Okay. So here we see a slightly different output than before, as it is taking 1290 and then multiplying that by 1.67. Okay, line number 1500. I have John, and in the next line, I'm replacing that with this is my library, right? So let's rewrite it as whatever is the value inside that variable, and I want to concatenate with that a value I. Save the changes and compile. And here you can see that it says John and a long text after that. It doesn't concatenate the value because I'm using the same variable back to itself. It just overflows. So since it overflows, it just doesn't do anything. See, when I'm saying character 10, it means John plus 6 spaces. That's what it means. So when you try to store, I mean, like when you try to change the value like this without using a built-in function trim, it does this. We will learn about string functions in the next chapter. So that's where we're going to explore that. So just wanted to show you that one thing, that how it does it. Okay. So let's change it back to Sammy. And we will now use this in the next line. Next line is a longer variable, right? So I can say that character 10 and I want to concatenate that with Isaac. Save the changes. Let's see.
Oh,
OS, compile. Let me compile this again. What's happening? Oh, I'm not calling. Okay. Here we go. Here we go. It says Sammy and then leaves 5 spaces, Isaac, and then leaves another 10 spaces. Because Sammy and 5 spaces is 10, plus Isaac 4, that leaves another 10 for 24. Now, instead of tcat, I want you to use bcat Isaac. So I only want to use 1 space between Sammy and Isaac. So it's 1 blank space. Save the changes. Compile it. And then let's call it. And then let me check the spool file. And let's check the dump. As you can see, Sammy, 1 space, Isaac. Okay, one last change is we will change the bcat to tcat. Save the changes and compile. And now let's run it. Check the spool file. And now Isaac and Sammy are next to each other with no spaces in between because of the tcat. Okay, so for this week, you guys have been assigned a quiz on chapter number 5. And I am assigning you some of the questions from chapter number 8 from the review questions section. So next week, we will be transitioning to chapter number 9. And that will go with control structures in a little bit more detail. That's where chapter number 9 is. And then chapter number 10, the week after that, is about expressions. So these 2 chapters will pretty much deal with some more programming constructs. Anyway, so we'll stop here for today.